Shall I start, Madhu?
Yes, it is. Start.
Okay. Okay, great. Hi, everyone. Myself, I'm Sravani, working as a program manager, and I'm here with my colleagues Rohit Nayak and Madhumita Tripathy. We all work as program managers for database platform security team, which focuses on Azure SQL security portfolio. Today, we are here to discuss about the SQL security for Azure SQL database that helps you to protect your data in the cloud with the latest security enhancements for Azure SQL database. We are going to talk about a quick overview of security portfolio for Azure SQL database and some of the new security enhancements with respect to data protection, uh, that is with TDE, CMK enhancement, and Azure Active Directory enhancements, and a quick intro about the ledger. We also have topics to be covered for connectivity and network security that will go about TDS 8.0, outbound firewall rules, and service endpoint policies. So this will be our agenda for today. So Azure SQL database is known to be a most secured database platform for our customers, providing various layers of protection, right? So we have Azure Active Directory, which helps customers to uh, modernize their identity infrastructure and manage their users and groups centrally using Azure Active Directory. And Azure SQL Database supports Azure Active Directory authentication, which helps which comes in parallel with your SQL authentication, so that you don't have to worry about maintaining passwords and things like that. It's centrally managed, so customers can actually concentrate on modernizing their applications along with modernizing their identity. So that support we have for Azure SQL today. Then encryption, as I think our customers know about SQL encryption for several years now, and we have encryption enabled at various layers of the database, right? When database is at rest, when database is in transit, and when the customers are using the queries. So even in memory also we have encryption enabled with always encryption feature. So we have encryption enabled throughout your data access layer. So that way we can protect your data in the best possible way. And we also provide you data protection offerings where along with data protecting data at rest and data in transit, data in use, we also provide you several other ways of protecting your data. Example like dynamic data masking, where we allow users to configure or mask their data based on the user rights. So any user who is not an admin or who don't have required permissions, they can still they will only see masked data, and they cannot see any confidential or sensitive information, right? So similarly, we have row level security, where you can even secure your data at the row level based on user context or execute as user. So based on certain rules you define, you can even define your rules at the row level, so that who can access or who can see what row data from a specific table. Along with this, we have auditing and threat detection. Auditing helps you to meet your regulatory compliance, and it's important to know what is happening in your database. So, audit allows you to analyze and assess your database, what actions are performed, and it also helps you to identify if there are any anomalies that happened in your database. And we also provide threat detection, which comes with the Azure Defender, which is like on top of auditing, you can enable threat detection, and this helps you to again detect any anomalies that happens inside your database. And it also provides you an opportunity to configure alerting mechanism where the user can take a specific action whenever you detect something wrong happened. So the auditing log with the threat detection provides you ability to identify potential threats and take a necessary actions based on your organization requirements. Along with this, we also have the vulnerability assessment, where the database you can run vulnerability assessment and detect your vulnerabilities within your database and then address them based on the again based on your policies, right? We have data discovery and classification, where you can discover your data, and then identify the sensitive information and then labelize them and generate reports based on what you have, what kind of data you have, and we retain the metadata of your sensitivity information so that you can access your data based on the sensitivity, right? So along with vulnerability assessments, we also provide data discovery and classification. Along with all this, we also have the compliance requirements. So the SQL Azure database regularly go through a lot of auditing, right? And it helps us to meet a lot of compliance with respect to, it could be an international compliance or a regional compliance, or it could be industry specific compliance like a military or a medical, things like that. And the SQL Azure database today meets most of the top industrial compliance like ISO or HIPAA or the FedRAMP, lot of these compliance, and we go through the auditing at regular basis. So hosting your application data in Azure database also eventually meets all these business requirements and all these business required compliance that is required to be hosted in the cloud. So being said that, so this is how we can present your data. When the customer data is hosted in Azure, we have all layers of security, right? The physical layer security where the data is at rest and data is at rest, and then we have the network security where you can secure data. I'm going to just give a quick overview of each of these layers in the next slide. But we also have access management where you can manage your access, right, using authentication and authorization. And we also have RBAC policies where you can have a role based access control, who can do what when you have a specific set of resources defined in Azure cloud, right? So we support RBAC, and even SQL supports RBAC. Azure SQL database supports RBAC, the role based access control. Then we have threat protection. Like I said, with the help of auditing, we can do a advanced threat protection and provide you ability to detect the anomalies that happens in your database. And we also have this information protection, which is again, I think recently we started supporting the Microsoft information protection, which is currently released. And we also have a native SQL information protection where you can define the confidentiality. You can labelize your columns, and you can create manual rules as well based on the data. So if you see, the customer data is sitting in Azure, which has all these layers of protection and makes the SQL Azure SQL database to be the most secure database to host your application data, right? So like I said, in the network security layer, you have the firewall rules where you can control what kind of connections you want to allow. Like with respect to, you can create a firewall rule at the IP address level. You can create a firewall rule at the virtual network endpoint level. So, and then we have these network security groups that can be used to achieve network security. And we also have private link where you can allow your group of database group of applications to communicate within a specific VNet or using the private link, right? So that way we provide the all types of flavors of network security for you to choose which one is more best option for your application. Then the identity and access, like I said, we support Azure RBAC, the role based access control. You can have multiple roles defined for your access control limits, who can access what, which resources, what permissions you can give to your resources within the resource group, things like that. And then we have the support for Azure AD authentication and the SQL authentication. And recently we started supporting Windows authentication for SQL managed instances. So with Azure AD authentication and SQL authentication, you can control your authentication that happens to the Azure SQL database. And You also have control over the authorization, where you can specify what group of users can have what kind of permissions, what data they can modify. You can assign the database roles, the server roles to the group of users that you want to authorize against your database. So this way we provide you both authentication as well as the authorization permissions that you can enable for your database users. Along with this, we also have the row level security, where I was talking about using a specific context or execute as user and allow them to see a specific set of group of rows within your table. So that is the row level security that we provide, which you can access the subset of your data, right? Then the data protection, when we talk about the data protection layer, again the encryption, where we have encryption at rest, that is the transparent data encryption. We have known transparent data encryption for several years now, and we are improvising like the performance, the ability to encrypt all of that, right? You can encrypt your files at rest, the data file, the log files. You can encrypt your backups, so that way everything at rest is protected. And then we have encryption in use, which is the always encryption, where I was talking about encrypting the data in memory while the customers are running the queries, right? So that is always encryption feature. And then we have encryption in flight, which is basically the encryption in transit, the TLS. And we have the user managed keys. We started supporting user managed keys. We have a demo uh, to show in the future slides. And of course, the dynamic data masking, right? So I'm going to explain what is dynamic data masking in coming slides. And in terms of security management, again, we have advanced threat protection, SQL auditing. Of course, you can audit server and database level auditing you can enable, and you can also enable advanced threat detection and configure to send alerts to your team so that you can take the necessary actions. And we also enable auditing integration with the log analytics and event hub. So this is very nice feature where it gives you security insights so that you don't have to really manually go through the audit logs to understand or to visualize what is happening inside your database. So the audit integration with the SQL Monitor, that is the log analytics and event hub, enables you to have SQL security insights that provides you a dashboard view where you can basically have a quick overview of what is happening, like how many connections, how many different IP addresses, or how many users, how many failed logins, things like that. It gives you a nice dashboard view. And then we have vulnerability assessment, which helps you to identify if there are any vulnerabilities in your database, like users with not strong passwords, or some sensitive data not getting masked, or things like that, right? And we have data discovery and classification, which is very widely used and very well known in the SQL market. So it's basically discovery, classifying your data based on the sensitivity and labelizing them and using them based on the sensitivity information that you have. Okay, and we also have the Azure Security Center, which also provides you the required security capabilities for your Azure SQL database. So, since we spoke about the overall overview of Azure SQL database, what we are going to do is I'm going to quickly talk about some of the capabilities that we just discussed, and then we will move to the improvements part. So, when it comes to the encryption, as I said, we have encryption at again various levels of the database. So in transit, at rest, and in use. So in transit, it's basically the transport layer security from the client to the server. So it protects the data between the client and server against any snooping or any middle attacks. So that is your TLS, and Azure SQL database supports TLS. We are going to talk about TLS more in the coming slides. And data at rest is protected using the transparent data encryption. This can be enabled and disabled from the portal. And by default, transparent data encryption is on for your SQL database. So for the existing and newly added database, the transparent data encryption is on. That means all your data files and the backups that you take, which are on the disk, are protected. And the key management is done by Azure. When you enable TDE for your on-prem servers, mostly you need to do a lot of configuration things, right? Creating the master key, creating and then enabling encryption, and then wait for the encryption to complete, things like that. So all this is done by the Azure. So you don't have to do anything. It can be simply managed from the Azure portal. You can turn it on and turn it off, but by default it is on so that it meets the required compliance. And the encryption in use, again, this is one of our favorite features, where you have the always encryption for the client side column encryption. And when you use always encryption, the data that is in use is encrypted end to end. While querying, it is encrypted even in memory. So application is aware of the encrypted columns. This is used in advance of data masking and TDE, so that you can even encrypt your data in use and meet the compliance related scenarios. So now the information protection, this is basically the information protection which is integrated with our Microsoft information protection framework. This helps you to protect the data and moves across database boundaries in your organization. So this again works in three phases: the discover, classify, and labelize. So the automatic data discovery and recommendations to classify sensitive data, and each column associated with a sensitive label and a label type. You can also do a manual classification if you have a specific business requirement. You can also do a manual classification on your data, and you can add your manual classification. And the column label is persisted as a column metadata as new classification attributes in SQL engine. And you can export and import the classification information to a report, and you can use the information for auditing purposes. So once the column is labeled, it can be used for auditing and protection. All labeled columns will be fully audited at runtime for any queries that access them auditing. And you can monitor which users are accessing what kind of sensitive data and how much sensitive data they access. You can even enable auditing for the sensitivity data. We have certain action groups that can be enabled when you have columns which are enabled, which are labelized as a sensitive columns. So the auditing is integrated with your data classification. So this is how the data discovery and classification looks like in the portal. I'm going to show a quick demo where you can see what is happening. But if you see here, you get the information type, like what kind of information. Is it a name? Is it a contact information? Or is it networking related? And then we also have a sensitivity labels where whether it's a highly confidential, GDPR, things like that. So this tells you like this basically discovers your entire database and gives you the list of classified columns and what kind of data classification that they carry and what kind of sensitivity that they carry. And also it comes up with the labels that you can classify using your column. So here you can also do a manual classification if you have any specific requirements. So this is how the data classification looks like, and it also gives you the recommendations where you can select and save those classifications. And if they are irrelevant, you can remove the recommendations. It's completely depends on your business needs, but by default, it enables you. It provides you an ability to discover and classify your entire database based on the sensitivity of the data. Moving on, let's talk about the dynamic data masking. As I said, this is another data protection layer that we have for Azure SQL database, where you can limit the exposure of the sensitive data by hiding it from the users. So you can mask and unmask based on the access level that you want to give it to the users. So dynamic data masking, again, this is again available for all versions of SQL. on-prem as well as the Azure SQL database. And when it comes to Azure SQL, again, it's completely maintained by us, and you don't have to do anything. All you have to do is just enable it from the portal. So auto discovery of potential sensitive data to mask. So this gives you an ability for Azure SQL database where you can automatically detect what kind of data that needs to be masked, and you can do a configurable masking policy from the portal, or you can even create a masking functions using the SQL Server Management Studio, where you can run certain DDLs to create those mask functions. And we also have a flexibility to define a set of privileged SQL users who has the ability to unmask the data across at a granular level, like a database level or a schema level or a table level. So you can provide that unmask privileges to certain group of users who can actually see the real data, while your application users might be seeing the data which only they are allowed to access, and the rest of the data can be still masked. So for example, I have a quick example here. Like for let's say you have a business application that access a employee table, and the employee table might be having a lot of sensitivity data like a social security number or an email address, personal information, or salary details. So what you can do is you can define masking functions. So there are a lot of inbuilt masking functions that are available in SQL, which are supported for both Azure SQL database as well as on-prem, like SSN or email. So these are the inbuilt, even the random. So choose picking something random between given range. So you can use these inbuilt functions to mask your data. So this helps you to again to meet your regulatory compliance, or it helps you to do any kind of hardening of your data and things like that, right? So so here basically I'm just doing certain some masking for my employee table, and masking the columns with some inbuilt functions like email or random. And I'm also providing an unmasked access to a specific user who is an admin user, right? So let us say when application user selects from employee table, this might be what happening. So if you see, when an admin run a select query against the employee table, they might be seeing the real data because they are given unmasked permissions. So they can see the real data for social security number and email salary here, while any other login that doesn't have unmasked permissions, they will be seeing random data which is basically masked using certain functions, right? So like some of the examples that you might call out is like somebody has to access credit card information, and they don't have to know the entire credit card number, right? Probably the last 3 or 4 digits of your credit card. So that is when probably you just have to go ahead and mask the credit card numbers using one of these masking functions that we have. So that is how the data dynamic data masking works, and it provides you another layer of data protection. Now let's talk about threat detection. So threat detection is again helps you to detect any anomalies that happens in your database that could indicate a potential threat. So you can configure the threat detection policy in your Azure portal, where the Azure database is sitting. And from the Azure database, once you configure threat detection, you can configure alerting mechanism where you can send a notification to group of users who can take unnecessary actions for the anomalies that are identified. Okay. And you also see, if you also have auditing enabled, you can explore your audit logs around the time of the event to understand more about what kind of activities were running at that time. So this is how the threat detection works. So once you configure auditing and once you configure threat detection, so another important thing is these two work in parallel. You do not, it's not like you have to enable auditing from the portal if you want to use threat detection. It is completely up to you. And in the backend, we enable the required APIs, and we collect the required data if threat detection is enabled. So once we configure auditing and threat detection, you can also configure the alerting mechanism. And whenever we detect something anomaly like a failed login or something critical, we will send a notification to the group of users where what what anomaly is detected, and then what kind of action needs to be taken for your database. So for example, here I have an alert where a potential SQL injection was detected in your database uh, starting time, and then you have to, since you have the starting time, you can go back and check what is happening inside your audit record. And you can see here is my audit record, which shows me somebody is trying to query a select statement and trying to get some complete details of a user, right? So that is how the threat detection works. And Azure SQL database auditing. So this is going to be my favorite topic as I'm working as a feature PM for auditing. So if you need anything to do with auditing, I think that would be me. You can reach out to me. So Azure SQL database auditing is known to SQL customers like from 2008, and it exists for several years now. And we have been adding a lot of action groups that provides you the most crisp level of auditing that you can do for your database. So Azure SQL database also pretty much supports most of the action groups that are required for your database auditing. Uh, so again, this can be configured simply from the portal. You can enable auditing from the server as well as the database level. Server level auditing, when you enable server level auditing, this is applicable for all your databases in the server, in your logical server. And if you enable database level auditing, it's applicable only for that specific database. And auditing can be configured either from the portal, or you can configure using the tools like the Azure PowerShell commandlets or ARM templates or REST APIs. But when you enable it from the portal, auditing is the default auditing comes up with certain action groups. So this is one of the very common scenario that I have seen where customers enable auditing from the portal, and they complain that there is a lot of activity getting recorded in the auditing logs. So when you enable from the portal, there are three action groups that we enable by default. That is failed database login, successful database login. This is to audit failed and successful logins for your database. And the other action group, which is introduced newly in SQL 2019, that is batch completed group, which is basically audits everything that happens in your database, every transaction that happens. So unless you have a critical database where you want to audit every action, you may not have to go for the default auditing. And if you want to enable a specific set of action groups to meet any security requirement or a compliance requirement, you can always do a custom auditing with a specified group of actions. But for that, you cannot do it from the portal. You have to do custom auditing by using PowerShell or ARM templates or uh, uh, even the resource APIs, right? So for that, we have a Technic blog with all the examples, which you can refer and configure your custom auditing. So with Azure SQL Database, you can achieve this layered approach to security. This is a quick overview of what we have. I mean, I think we surely have a lot of layers of protection to protect your data, and the best and good news is it can be just done from the portal. You don't have to do anything. Just you just decide to enable, disable something, and everything is done in the back end, right? It's not like you need to run a lot of scripts or understand or configure. Nothing. It just can be done with from the portal. So that is how it works. So you can secure your database using firewall, permissions, users, and connection string encryptions. And you can secure your data using encryption, data masking, and row level security. And you can also secure the changes to your data by using application and user activity, by logging your application and user activity through auditing. So this way, we provide all layers of security for your SQL database. And I will show a quick demo from the Azure portal before we move on to the new improvements. So this is my Azure portal, and this is my one of my sample database adventure walks, where I just want to show a quick demo. Like I said, the entire security portfolio can be managed from the portal. So this is your security blade for my database, where I have all the layered features that we were talking, right? The auditing, ledger, data discovery, classification, dynamic data masking, Microsoft Defender for cloud. This is the one which I was talking about, the advanced threat protection, and then we have the transparent data encryption. So if you see here, the like I said, the TDE is on by default, and then you can turn it off if you want. That is, if you feel the database is not critical, or your test databases or dev databases, you can always turn it off. So this is again done from the portal. It's so simple, just a simple switch. You don't have to worry about creating any master key, enabling altering database to enable encryption, right? Similarly, if you see, this is my data discovery and classification blade, where if you see, it says currently it's using SQL information protection policy. So with that, we already have some 15 columns with classified recommendations. So here are my recommendations from data discovery and classification. So if you see, it tells me what kind of, which table, which schema, what column, and what is the information type, and then what is the sensitivity label. So you, based on this, you can decide whether you want to retain this information, or whether you want to just ignore this sensitivity label information, right? So so this is also again done by default. I don't have to do anything unless I have to do a manual classification. If I want to do a manual classification, you can always add a manual classification from the portal here. And this is auditing. For auditing, if you see, we support both server level auditing as well as database level auditing. So my server level auditing is already enabled, and database level auditing is not enabled. If I want to enable database level auditing, if you see, these are the three targets that we support: storage, log analytics, and event hub. So you can configure your auditing to any of these targets and start using auditing for your database. So we also provide view audit logs option from the portal itself, where you can directly go and click on view audit logs, and also check what happened in a given specific interval. And we also provide you this log analytics dashboard if the auditing is configured to log analytics target. So yeah, so that is about the security blade, which has everything that centrally can be managed for your Azure SQL database. With that, I will hand it over to my colleague Madhu, who will be talking about some of the new enhancements from security.
Yeah. Thank you, Sravani. Okay, I'm going to share my desktop. Hi everyone. My name is Madhu and I'm working as a PM in SQL security team along with Sravani and Rohit. I primarily focus on data classification, dynamic data masking, and purview integration for the data classification feature that we have in SQL. So Shravani covered it very well overall, what all security features we have and the different layers of security which are available in Azure SQL, and the same are available in SQL Server as well. So we will see some of the very good improvements that have come in security space for Azure SQL, and some of them are going to be available in SQL 2022, which is in public preview, and we will have a GA almost by end of this year, and that's the current plan. So let's move ahead to the very first improvement in security space. So this is all about managed identities, which are supported in Azure SQL DB and MI. You would have heard about system assigned managed identity, which was already there, and what's new is user assigned managed identity. So there were certain limitations with system assigned managed identity, and for which we thought that it is important we come up with user assigned managed identity. So first of all, what is managed identity? So we have different kind of secrets, certificates, and credentials which are needs to be managed by the developers or the users. Now it's becoming a challenge for the developers to manage all these in a automated workflow or in an application code. And it's not a good idea that all the credentials, passwords are spread across different code and workflow, because the manageability becomes a problem and it's not that safe. So now what happens is, so with managed identity, the developer need not store these credentials or passwords within the code. Rather, by using this automated managed identity, which gets created in Azure AD, all these authentication will be taken care in the backend without even maintaining those credentials in the code, in the application code or in the workflow. System assigned managed identity to some extent helped achieve that, but there were certain limitations, as I mentioned. So the primary ones are, the system assigned managed identity is tied to the lifecycle of the Azure resource. Let's say you create Azure DB server, and so system assigned managed identity is associated with that resource. Now, if you drop that Azure DB server, which is a logical server, then you are losing the system assigned managed identity along with that, and it's dedicated to that resource, so it cannot be shared. Let's say if you want to use that managed identity for any other resource in Azure, you will not be able to do. So because of these limitations, we came up with user assigned managed identity. So what happens here is, you independently create managed identity in Azure AD, and then you can use the same managed identity for multiple Azure resources or services. And at the same time, you can create multiple user assigned managed identity and use it for different purpose. Like, let's say you want to create one user assigned managed identity and use it for TDE encryption with CMK. Then you can create another user assigned managed identity and you use it for Azure AD authentication. So you can see that if you drop the Azure resource for which you are using that user assigned managed identity, if you delete that resource, your user assigned managed identity doesn't get deleted along with that. It stays there in Azure AD, and you can use it for in future, or if you don't need it, you can drop it. But it's independent, it's not tied to the Azure resource. So let's quickly move on to the next slide, which talks about the two scenarios that we basically have, where this UMI is going to help a lot. So you can see the scenario one, where while creating the DB, the Azure SQL DB itself, you can specify that you want to enable TDE with CMK, and you want to use user assigned managed identity for that. So the workflow would be like this, that first of all, you create the user assigned managed identity in Azure AD, and then you create a key vault where you want to store the key, let's say, which will be used for TDE encryption. So you store the key in the key vault, and then you assign required permission to this user assigned managed identity to access the key which is stored in the key vault. After that, so the server itself is not created yet, right? The Azure DB resource is not created. So you took care of creating the key vault, storing the key there, and granting the required permission to the user assigned managed identity. So that is independent of creating your resources. Now, what you need to do is you create the Azure DB resource. So during the creation itself, you can specify that you want to use user assigned managed identity, which you have already created, and you want to enable TDE with CMK. So you can see that this particular improvement will enable you to create certain Azure policies which can enforce that whenever, let's say it's a production environment, and as per your regulation or compliance of your company, there is a mandate that whenever new server gets created in production environment, it should have TDE enabled. So you can see by this improvement, you can create Azure policies which will enforce that during the server creation, it has to enable, the TDE needs to be enabled with customer managed key. And the second scenario, which is definitely going to be very helpful for automated workflow and your application, let's say it could be any .NET application or any other application which talks to Azure DB or MI, you can use this user assigned managed identity for Azure AD authentication. So you are not going to store any credentials in your application code, and it removes the password usage, which is tedious to manage, of course. So these are the benefits which I mentioned a while ago, that so you still maintain those user assigned managed identity even if your resources are dropped. And particularly with CMK, the TDE with CMK scenario, you can see that during the server and database creation, you can create these, you can specify TDE encryption, which will use the user assigned managed identity. Let me see if I have a demo. Okay, so I'm not going to create a server end to end, but to make my demo a bit short, I just wanted to keep things ready so that just a moment. Okay. Okay. Yeah, so if you see here, I'm in the Azure portal and I'm trying to create a new Azure SQL database. So I have already filled up the basics and networking section. I'm currently in the security section. So if I go down, you can see there is a new option for Ledger. I will talk about Ledger briefly in one of the slides. And this is the identity section, which says that if you have any user assigned identity enabled, or if you have already created, you can configure that here. So if I click this link, it takes me to this page where it says that do you want to use system assigned managed identity, or you want to use the user assigned managed identity. So if you see here, I had already created this the user assigned managed identity, so which I have already added here. Probably I can even remove and click on add, then select it again, but the fact is I have already created and assigned it here. So let's cancel this, and let's go to the TDE encryption part. So if I click on this link, you can say that, okay, I have a customer managed key. So let me select this option and I want to say which key it is. So it goes to the next page and I say, okay, key vault, I need to select my key vault. So let's say, let me select the one that I created. And I had already created this TDE key. So I can select that, click on select and apply. Right. So you saw that I kind of configured the user assigned a managed identity. And then I say that, okay, I want to enable TDE during the creation of the server itself. And this user assigned managed identity already have the access to get the key from the key vault during the server creation. So that was the demo all about. So I'm not going to fill up the other sections. It will definitely take some minutes, and we have a lot of content to cover. So let me quickly go back to the slides. Okay. So moving on to the next improvement, which is the new built-in server level roles, which are available or in public preview for Azure SQL database, and they are also going to be available in SQL 2022. So first of all, you must be thinking that, okay, at least for SQL 2022 or for on-prem instance, we already had a lot of server level roles. We will come to why we are introducing these built-in server level roles for the on-prem or SQL instance. But while talking about Azure SQL DB, we all know that when we talk about server in Azure SQL DB, it's more of a logical concept, right? It's not like same as what you have in on-prem, like an instance or like a managed instance in SQL. It's more of a logical server. Now, granting permission at the server level in a logical server, not possible, or you should not be granting any server level permissions there. So what was happening is, so let's say you have certain system-wide metadata or some some kind of management commands which need certain permissions which is at the server level, then you end up granting server admin role or AD admin role, which is the most privileged one. And definitely we didn't want to grant server admin role for everything where you have to access some system wide metadata and stuff. So we wanted to make it very specific based on what action the user is going to perform. So based on the duty, which we say separation of duty or principle of least privilege. So whatever is required, just grant only those permissions. So to make it the least possible permissions or roles that should be granted, we thought of bringing in this new improvement wherein you will have very specific server level roles for certain activities. And we wanted to enable it for the on-prem environment as well, so that that facilitates the migration kind of scenario. So you have similar kind of roles in on-prem and you have similar kind of roles in Azure DB. So the next thing is, yes, so the next point I already covered, wherein you need not grant server admin and Azure AD admin for everything. Rather, you just assign the specific role which is required for that activity. Next thing is they are granted to the logins which are created in the master database, because that's the logical master actually. And so these roles are actually designated with hash hash and then MS and then the server role name. We will see those names in the next slide. And it applies to all the databases in that particular logical server until unless the last point, which is you say deny explicitly for certain database, it is applicable to all the databases. So moving on to the next slide, where we are talking about these, I think this is close to 7 new server level roles that we have introduced, and there will be much more in future. So the last 3 were already available, I think around September or October last year, and we have introduced the first 4 that you see here in the list recently. And just for an example, you can definitely read about these specific roles and what they do, but let me pick up the first one, which is MS database connector role. And so I talked about the least privileged permissions which are required for your duty or role. We brought in the new improvement. And then another factor or motivation was, how do we make it scalable? So for an example, in a logical server, you have around 50 to 100 databases. Now, you want to grant a connect to a login for each of those databases, let's say 50 or 100. So you end up creating users for inside every user database, right? Now, with the help of this server level role, what you can do is you created the login and in the master, and you granted the which is a server level login, and you added that login as a member of this role, which is database connector. So what will happen in the backend is, once the login is added to this role as a member, it will get connect any database permission on the server. Means it can connect to all the 100 databases, even if you don't create any specific users in those databases. So by default, it gets connect to all 100 databases. So you can see how scalable it is. So that was one example. Probably I can show you a demo on that. And this is the syntax wherein, and it is, so the other fact is this roles are supported for SQL logins, for Azure AD logins. You can see in the slide, I have an example of how you create a login, AD login, because there is external provider clause which is used here. And then you added that login as a member to this role. So let me show you a demo on let's move on to the demo. Okay. Okay, so here I'm not using AD, means I have definitely connected. So this is my server, the logical server where I have connected using AAD login. And next thing is I have a small script as a helper for the demo. So you can see here that, let me just verify if I have dropped this login. Okay. Yeah, so the login is not present. And I'm just creating a normal SQL login. As you can see, it's not a AAD login, but if you want, you can do that as well. It is supported for both SQL and AAD login. So let's create this, and I want to add this login as a member of MS Database Connector role. So let's execute that. And after I do that, okay, so there is a limitation today. Definitely, we are working on it to improve, but there is a lag of 5 minutes till, by the time it takes effect, we are estimating that it will be almost 5 minutes. So if you want to make it faster, then there are certain workarounds, like you can see on the screen. Now I'm going to run dbcc flush auth cache. So let me execute that quickly, and let me see if the login is able to connect to one of those databases. So let's say, okay, I think I created server login 1. So let's enter the password and go to the options. So I am connecting to one of the database where I have not created any user or anything. And let's go to the login, and this is a SQL login. So let's see. Okay, so you can see that the login was able to connect without even creating any specific user in that database. And that completes the demo on this new server role. Let's quickly move on to the slides. Yeah. So you can see the so some of the benefits we already discussed, that you can easily manage these permissions at the server level and make it scalable as well. And MS Database Connector, we already discussed how you can scale it for multiple databases, this connect permission. And yeah, it supports SQL, Windows, and AAD authentication, all of that. We saw a demo using SQL login. And next thing is, yeah, this also I mentioned that for certain management commands where you need admin kind of privileges, or you were granting server admin, that may not be necessary, and you can leverage these new roles, which will help you achieve this principle of least privilege and then separation of duty. Okay, so we covered the demo. Let's move on to the I think this is blocking. So okay. Yeah. So Azure AD authentication enhancements. So this is the first section we already discussed, which is more related to the user identity management enhancements that we saw with how to use that during the server creation, enabling TDE with CMK. So these are the points that I'm talking about in the very first section. Let's see the second one, which is also GA, Azure AD only authentication. So now you can, completely disable SQL logins for Azure DB and managed instance, and just enable Azure AD only authentication. Similarly, during creation of a new Azure SQL server, you can say that you don't want any SQL authentication and just want AAD only authentication. And you can also create Azure policies which will enforce that there should not be any SQL authentication at the server level. It should be only AAD only authentication. So these are some cool features. And then now in Azure DB, we also support creating Azure AD server level principles, and which are the logins created in virtual master in the Azure DB. Let's move on here. Okay. Yeah, so this is the syntax we already discussed in slide 1. If you are creating a login using Azure AD principal, then you have to use this from external provider clause. And while creating the user, the syntax remains same. Let's just create user and then from login. Yeah, so these are the principles which are mapped to the AD account. You can use AD login means users or groups or service principles. I think there is a typo, so I need to edit this is actually principals. And yeah, so once you create these external or AAD logins, if you want to figure out if these are the external logins or principals coming from Azure AD, you can query sys.server principals or sys.database principals and look for the type column which will say X, which stands for external. Okay, so
Madhu, sorry to interrupt.
yeah,
Probably for AAD and Ledger, we can direct them to the other detailed sessions that we have
yes.
from our colleagues, as we are running out of time, and probably we should move to connectivity and networking to have a more detailed conversation there.
Okay, certainly. So yeah, so AAD you will have a deep dive session, and definitely for Ledger you will have another deep dive session. So like as Sravani mentioned, we are running short of time, so we are moving on to the networking and security section. Thank you for watching. Over to you, Rohit. Uh, can't hear you, Rohit. Sorry.
All right, much better. Hello, folks. My name is Rohit, and today I'll be talking to you about connectivity and network security in Azure SQL and SQL Server all up. So let's start by talking about TDS or Transport Data TDS protocol. Now, this protocol has been around since the very beginning days of SQL Server, right? And the way it worked is always you have this pre-login packet and then followed by TLS handshake, and then everything after that gets encrypted by TLS. Needless to say, this is an older design and it has several security implications because that initial hop is made in clear text. What we are doing now is we are actually enhancing the protocol such that the TLS handshake happens in the very beginning, and such that everything that we do in TDS after that, including the pre-login and login packets, etc., everything is encrypted. Right? So why do you care about this as a DBA? So this makes your life simpler because now you're on a more secure version of the protocol where everything is encrypted from the very beginning. This also helps you in your conversation with your peers in the networking team, right? Because now things like network appliances can read this like any other HTTPS traffic, right? And finally, the big thing that this lets us do is because we are now doing the TLS handshake up front, this design also aligns with TLS 1.3, which is the latest industry standard for TLS. So that way we can bake TLS 1.3 support right into this protocol. Now this protocol was shipped with SQL Server 2022. And what it does is introduces this strict connection encryption setting. And that is how the customer would be using this TDS8, right? And we still have mandatory and optional, which correspond to older ways of connecting that you can still use today. So let me just quickly show you a demo of this. So what I've done here is I've set up a DSN pointing to one of my SQL servers hosted in Azure VM. I'm using the ODBC driver for 18 for SQL Server because that's what has the support for the strict connection. And as you'll see, this is common steps. I'm just going in, entering my username, password. And at this very last step is where I see all these various options, right? So optional and mandatory, as I said, are basically for backward compatibility. And strict is the new thing that we are introducing. And just to show you this in action, let me go start a Wireshark trace on the server. And then I do a finish here and I do a test data source. And you can see we connected successfully. And let's see what we see on the server side. So as you can see on the server side, right, there's that initial TCP handshake, but everything below that all these frames are encrypted right from the get-go, right? There is nothing that's sent in clear text ever. So that is the big thing that is going to hopefully help you and especially make your network admins happy. And that's on SQL Server 2022. Okay, so that was the demo. Let me go back here. Okay. And of course, right now it is on SQL Server. Eventually, we'll be able to support this on Azure SQL as well. But the one thing that we did enhance in Azure SQL database recently is this, the visibility into the TLS version that you are setting. So earlier on, like mid 2020 is when we introduced this setting called minimum TLS version that lets you enforce a version of TLS for your Azure SQL Server. And now you can actually go look at in the audit logs, you can actually see if you had a successful or a failed attempt, what was the client TLS version that was being used. So this way you can gain awareness about what is the version that your clients are using before you decide to enforce TLS 1.2 at the server level. Okay. So we talked a lot about TLS, and the similar theme that we hear from customers is a lot in the context of data breaches and data exfiltration. This is essentially where if you have a setting like this, where you have a DB1 on the left, and the way it is set up, it can talk to these multiple storage and database accounts, database servers by using different features. What customers asked us is, hey, give me a way to kind of and put a bounding box around my database server so I can define which are the resources, past resources that it can talk to, right? And the main reason they want to do this is they're afraid that if there's a malicious insider and they are able to maybe take a database backup to a storage account that's owned by them and not by the company, so then they can exfiltrate that data. So that's the protection that we are providing here. And the way we do this is we basically say there's a switch at the server level that says, do you want to restrict outbound network access? Which means, do you want to put this kind of perimeter or fence around your database? If you say yes, then you need to provide us with an allowed list of other PaaS services. Mainly this is storage and SQL database at this point that are allowed to communicate with this DB1 instance. Currently, it is, as I said, mainly focused on features that deal with storage, such as auditing, vulnerability assessment, import, export, etc. And then we also build support for it in Elastic Query, which is the one feature that we know talks from one SQL database to another. Right? So hopefully, customers find this useful and in allaying their concerns about who can move my data somewhere that's outside of my control. Right? Now, what we'll try to do is take a look at how we do the same thing, but with managed instance. So similar setup in managed instance where you have managed instance runs in a VNet, and then you have these ports open so it can talk to Azure storage, right? As it stands now, by default, it'll, as long as the port is open, you can communicate to any of the Azure storage accounts that you wish to communicate to. So we have two storage accounts here, backup storage and unsafe storage. And of course, our intent is to disallow or block access to the unsafe storage. So let's see how we can do that. So step number one is to enable a service endpoint for Azure storage on the VNet side of the managed instance. So when you enable a service endpoint, what that means is you want this traffic between managed instance and Azure storage to stay within the Azure backbone, right? So it's not going out on the internet and coming back in, right? That's step one. So then you get into this sort of picture where the traffic is just within our data center, but you still haven't solved the problem of I can still write to both the storage accounts. Then the way you restrict access is by defining what is called as a service endpoint policy. And it has kind of a programmatic syntax to basically say you only want to allow access to backup storage, right? And once the policy is enforced, then what happens is you can no longer access the unsafe storage or any other storage that's not in the policy. So this is how we do data exfiltration prevention on managed instance. And that was kind of a high level talk on what's changed in network security and connectivity. So thank you, and we'll pause at this point.
Thank you, everyone. Since this is a recorded session, we will be available in the chat when the recording is played, and we are open to answer any questions. While you listen to the recording, you can continue posting your questions in the chat, and we will be more happy to answer all your questions. Thank you so much for listening to us today.